Productions. Some of you may have seen that I posted up a Shimmerverb algorithm on the Mastering Vast forums the other day. So I'm just going to do a quick video today showing you how I did it. And for those other people that are on the internet that are, found their way here because, Kurzweil Shimmerverb, it's kind of cool and new and groovy, eh? What we're going to do is look at what's available in the existing hardware that we can emulate this popular effect. So let's get up, and I'm going to program this on the Forte, though I've also done it on the KSP8, and you can go back and do it on pretty much any of the keyboards or effects units that have KDFX in it. Alright, I'm just going to move over to the keyboard. I'll see you in a sec. Alrighty. I made it here, hopefully you can see me. There we go, that's a bit better. Alrighty. So, the Shimmerverb, so it's currently a popular reverb from both Eventide and Valhalla. So they're the two companies that really, have published this of late. And essentially what Shimmerverbs are is that they're a pitch shifting algorithm that feeds into a reverb, and then there's a feedback path back around to the start of the reverb again. Each of the companies do, things a little bit differently. Valhalla have dual pitch shifting available, and Eventide seem to have a much cleaner and nicer and more heavenly Shimmerverb, I guess. And I guess both of them do things in slightly different ways. Eventide, were really famous for their pitch shifting algorithms, and which is essentially the way they do it is they have a rotating sample buffers with smooth crossfading, and it maintains sample accuracy between the two buffers. Valhalla uses grains to repitch in a similar way to how Ableton do their pitch shifting. Now, Kurzweil aren't really strong on the pitch shifting front. They don't, their effects units and KDFX are really strong on the delays and the modulation type effects that, use delay lines and filtering. However, hidden away, right at the back of the KDFX version 2 manual, which you'll see here, is this little gem, which hopefully you can read. It's called the Wac Pitch Lfo, and it's really, I guess, Kurzweil's attempt at using what they've got in their toolbox to create pitch shifting. They've got things called pitches in there. And pitches are essentially a comb filter that lets through frequency-related content to create pitch, either out of a pitched content or unpitched content. But with the pitcher, they're subtractive, so they don't actually shift the pitch of incoming signal. They take the incoming signal and filter everything out that doesn't match the pitches. So, anyway, this is a genuine pitch shifting algorithm, and I'll just go through what Kurzweil's documentation say about the Wac Pitch Lfo. So the shifter works by using the same concept used to detune a sound in a chorus algorithm. In a chorus algorithm, an LFO is used to change the length of a delay line. By smoothly changing a delay line length from long to short to long, the signal is effectively resampled at a new rate, causing the pitch to rise and fall. In this algorithm, the signal level is made to rise and fall in time with the delay line movement, so that you would only hear signals from the delay line when the pitch is going either up or down. By overlapping and adding several delay taps moved by several LFOs, they can then process a relatively smooth pitch shifted signal. And then they put a big separate line there that says relatively. And in reality, you do tend to get Tremolo Effect. And the reason for this is that because, unlike Eventide, the sampling the sample lines are not sample accurate. So they in the Eventide they run two sample lines, and they're offset. And what happens is that they can run them at different pitches or different playback rates. And when this one gets to the end, it keeps track of what sample it's up to, and then it moves down onto the other one at the same sample thing, and that's how it builds up the time, or how it builds up and keeps the pitch shifting going. So it moves between these two sample lines at different rates depending on how much pitch shifting you've got. Kurzweil don't do that, so they don't keep track of the sample accuracy in terms of switching between the two sample lines. They do it with an LFO. And what can happen is, depending on your pitch shifting, is that you can get inversions in depending on your settings, you can get inversions in your phase. And when you get phase cancellation, obviously you lose volume and you get a beating effect because it's an LFO. There's a few things we could do about, we could look at trying to, randomly change the LFO amount. The Tremolo effect that we get is, well, let's see what Kurzweil will have to say about it. In reality, you tend to get tremolo effects that some of the delay lines can be out of phase. Slower LFOs result in less tremolo, but do produce some flanging. But also at the slower LFO rates, you use up a lot of sampling memory. So there's a bit of a trade-off there between the sampling, the amount of sample memory you need, and the smoothness of the pitch shifting. Anyway, I guess the upshot of this is that we can use this to build a Shimmerverb of sorts for KDFX enabled synths. So all the way back to the K2500, though K2500 and K2600 are pretty short in PAUs, and the Wac Pitch Lfo uses 3 PAUs out of the 8 that are possible. So you're limited then in what you can do with your reverb. But you could certainly build the pitch shifter and a reverb within KDFX, even on a K2500. So this is applicable. I've built this on the KSP8. I've built it on the Forte. I'm going to do it on the PC3, and the Forte ones I've done are compatible with the PC4 and K2700. So, we've now got a Shimmerverb for Kurzweil. So let's go. One of the limitations that we've got here is that none of the algorithms have feedback between algorithm blocks on KDFX. Apart from, you could repatch the outputs back into the inputs. So for example, on the KSP8, where you can feed 2 inputs into an effects chain, you could then feed one of those back around and you could create it that way. And I might give that a go one day and see how that goes. But what we're looking at here is what we can implement more readily on the synths. And one of the advantages that we've got here is the Wac Pitch Lfo does have a feedback aspect to it. So you can feed it into the pitch shifter and it will keep feeding around and it will keep building up those pitches. And that's one of the things that gives this Shimmerverb implementation a bit of a unique effect. It certainly can create some dissonances at higher frequencies and higher feedback rates. So it's sort of somewhere in between what Eventide provide and what Valhalla provide, because they implement their pitch shifting slightly differently. This sort of sits somewhere in between. Certainly good for the gritty type of stuff, but it sounds okay on, we're going to do this on your Adagio strings on the Forte today. All right, I'm just going through my notes here. So the Wac Pitch Lfo does have feedback, and what I'm using is the complex echo, which we use as a reverb in this. And the reason that I chose that is because it has the ability to feed back the delay lines back through the diffuser. So essentially what we do is we have a pitch shifter with internal feedback in it, and then that feeds through to a complex echo, which also has a feedback on it. So we can get the signal through, both things, so we can build up the pitch shifting feedback, and then we can get the smearing feedback through the reverb. So a little bit of a different implementation to what's available by Valhalla and Eventide, but you know, choice is good, and you know, this lets us do different things to what we can do with either of those two algorithms. It also gives us the opportunity to do things like EQing in between the two blocks, or things like chorusing or other cool stuff if we want to do that. Both Valhalla and Eventide, they do sound quite different, and the Kurzweil Shimmerverb is no different in that respect. It is more dissonant at high frequency, or particularly when we open up the high frequencies, and when we turn the feedback up on the pitch shifter in particular. And that, you know, when we're doing an octave at a time, and if we put a high feedback in, we're certainly going to hit the Nyquist limit, and we will get some folding of those samples back in. So having dissonance and aliasing probably isn't that unheard of, or not really that surprising, but we can turn down the feedback, and that eliminates those mostly. But again, you know, if you're into the industrial and your noise, aliasing could be your friend. It does some cool stuff. Right, what else we got? Finally, this is designed to be used on an auxiliary send. One of the reasons for this is that to get the smearing up front into the pitch shifting algorithm, what I've had to do is I've put a reverb on there that's pretty much 100% wet. So this is designed to be used as an auxiliary effect. So you blend some of this from your DAW through your effects unit, and then back in and mix it with the original signal. And one of the reasons for this is we want to try. I sort of base this on the Eventide algorithms. I have a H9000 here, so you know I can listen to them, and I suspect what Eventide have done, because if you know they keep this under wraps about how they, so we can't actually look inside and peer inside this algorithm. But I suspect what they've got is a pitch detection and filtering within their feedback paths to keep things sounding nice and heavenly. So what they do is they really just pitch shift off the fundamental frequency and build this, you know, beautiful bloom around that fundamental. And the reason I think that is because when you feed a sawtooth into the algorithm, the Eventide Shimmerverb, you don't get all the high frequencies getting pitch shifted. It's only around those fundamentals. So there's some sort of weighting or filtering or EQing around whatever the fundamental frequency of the audio process is. Anyway, let's get on to the Kurzweil Shimmerverb, and get to start the programming. So as you can see here, I've got 179, which is Adagio strings. So it's a beautiful string patch. Right, we're just going to go into the edit mode, and what we're going to do is go through the effects page. Alright, we're going to go down to the auxiliary one. It's already got a Symphony Hall auxiliary on it, which we can turn on by hitting number 5 and turning this up. Okay, and we're going to edit this and pretty much destroy it. So the first thing that we're going to do is that we're going to put, I'm going to put a natural, or the reverb on here, reverb number 2. And I'm going to go in and I'm going to edit this. So we can see we're 100% wet. I'm going to increase this up a bit. Give us a little bit more reverb time. I'm going to bring the high frequency damping down, which just to try and try not to feed too much stuff into the pitch shifting algorithm of those high frequencies. Again, this is to try and keep it in a similar sort of character, or going along that character to what the Eventide's got. 0 milliseconds, 0 milliseconds are all good. We're going to concentrate on the late level because we want that smearing. I'm going to bring the out gain down to 0 because we definitely don't want to be amplifying here. And the early reflection level, I might bring that down to 50 because I'm really after the smearing part, that later part of the diffusion of the algorithm here. So this one, I'm going to bring this back. I'm going to put this as a Hall algorithm. So I'll put Hall 1. I'm going to settle these back to their native scale sizes of 1. And this is EQ. We might use this a little bit later to be able, this is one of the places that you can control how much high frequency goes through. So let's just set these all to 1. We'll just turn off the LFO pitch shifting within here. Low frequency split, so we might pull this up to around about 250-ish, and we'll bring that, we'll make the low frequency time shorter so that we don't, again, bring as much of the low frequency stuff through into the rest of the algorithm. The early diffusion amount, we might just add a little tiny bit of that, maybe 10%. We'll leave the rest of these pretty much as they are. I might just stick this at 50%. Alrighty. So that's the first part. I'm going to insert into this post, and what we can do is we can put in a whole bunch of stuff here. I have been experimenting with choruses. They sound quite good at fattening the sound up, so go into this and make it good. But I'm going to leave it out, this one here. And what I'm going to do is I'm going to pull up the Wac Pitch Lfo. Now on the Kurzweil Forte and most of these, for some reason that I don't agree with, they have decided that everything now is a preset rather than the algorithms. I would much prefer it if we could just pick the algorithms and then build presets out of them. But we have to pick a preset that has the algorithm we want in it. The one that we're looking for is Wac Pitch Lfo, and one of the algorithms that's got that in it is 219, which is a nickel chorus. So the Wac Pitch Lfo is used, you can use it for choruses and it's other weird pitch stuff. Most of the presets that have been done around this either are a beautiful chorus or they do some really wacky robotic kind of things. So we're going to try and push this to use so it sounds a little bit nicer and slightly different application. Okay, let's go in and edit this. So what we want here is, I'm going to pull this wet dry up. We want it between about 60 to 100%. I'll start at 60%. Oh, let's just play what we've got so far. Oh, it's even that, it's starting to sound quite nice already. So the output gain, let's just go down this way. I'm going to start off with feedback at 0. LFO rate, I'm going to start that at 1 Hertz. Oops. And the low pass filter, I'm going to take that right down, 1100. The output gain, let's put that at 0. The high pass, again, we can bring this up. I'm going to probably bring it up to about 400. Now this pitch shifting, this is where we do the shifting. So 12 here, let's set that to 0. So now we can hear the pitch shifting going on. We can hear that it takes the note and it brings up and it adds into it these additional things. Now we can increase this, the feedback. And now we're starting to get some of these, some of these, oh. Right, so you can hear when we've got this feedback going, we have some of these higher frequencies that start building up and going around. Now, on the Eventide Shimmerverbs, you're quite limited in what you can have around these shift amounts. So they're based around fifths, sevenths, and octaves. On the one from Valhalla, you can set these to pretty much anything you like, and you can do the same here. This will go up as high as 24, and you can pitch down as well. So the pitch shifting down actually sounds quite nice as well. So essentially this is what we need to do. This is this pitch shifting now set up. Changing this LFO rate. So as we speed that up, it gets, again, really start hearing the effects, and as you slow it down, one of the options that you've got here is to set this frequency rate, in time with your, your tempo of your song. So, anyway, this is where we're going to set the nickel chorus up at the moment, or the Wac Pitch Lfo. And what I'm going to do is, after this, this is where I'm going to put in the other algorithm. So the one we're going to use here is complex echo, and one of the presets that's got this in it is the preset 170 multi-tap milliseconds. Right, so if we go into this, what you can see here is we've got this feedback and there's a diffusion here. And when we look at the, let me just find this for you. Complex echo, which I hope's in this one. No, the complex echoes in the other manual, but anyway, have a look it up on Kurzweil's website. If you look at the KSP8 algorithm manual, you'll see the complex echo algorithm there, and you'll see that it feeds back after the delays. There's 2 taps that come back, and they feed in with the feed before the diffusion. So that's how we're sort of building. We're injecting in the pitch shifted. So what we're doing is we're smearing it with a delay with a reverb up front. We're then doing pitch shifting on that smeared signal, which is essentially like, if we think about how Eventide do it and Valhalla, they pitch shift it and then they pass it through their reverb. So that's one block of pitch shifting and reverb. And then they feed it back around. So what we're doing instead is we feed the pitch shifted, we feed a smeared reverb signal into the pitch shifter. That then has got feedback in it, which allows those pitches to build, and then we feed it into another algorithm which allows that signal to feed into the reverb element, so that pitch shifted element goes in with goes around and around with the pitch shifting and whatever comes out of the reverb. So in this case we're going to set up this multi-tap milliseconds, so I'm going to set this to 73% wet. That could be 0. Right, diffusion amount, I'm going to crank this up to about 86%. So what that is this is diffusing that pitch shifter signal that comes in. So you can probably hear that already. So if we take this back down to 0. Yeah, it really starts taking off some of those top end edges. Okay. High frequency damping, I'm going to take this again down quite high, quite low, sorry. Just to take away again some of that high frequency content. Alright, parameter 2, these are the feedback algorithms here. Now you've got, there's quite a bit of what you can do. Now I'm going to pull these back quite a bit. So I'm going to extend these feedback layers here out. So this the feedback delay 1 and 2. These are the outside loops in Kurzweil's echoes, and then these taps is what comes out. So you can have a long loop, and you can pull taps out of that loop as it goes around with these times here. So let me just type these in quickly. These are by no means optimized, but it will give a bit of an idea of using this echo as a reverb. So what do we have here? 56, 104, and 170, and then we go 80. 165, Right, these are the tap levels, so we might just go 100, 75 and 50, which should give us a pretty dense reverb. Alright, so that's, oops. Alright, so both of these, you can hear how we're now getting this complex echo is now delaying the whole thing. Right, so we fed in the pitch shifted amount into the what we're calling a reverb, which is actually a complex delay, and it's going around and around and bringing out these taps. We're going to pan them as well, so we might just go. So we'll pan them left and right. Oops. Forgot to hit the down button. You could cross these over if you wanted to. All right, now that's essentially it. So we now have a algorithm. So if we exit out of this, we've now got an algorithm where we've got this smear up front, we've got the pitch shifter in the middle, and then we've got this complex delay, which allows us to feed back into the diffuser. So we put pitch shifting in, it gets reverbed and then fed back with the new pitch shifted information back into that diffusion. All right, let's save this. So if we exit out of this, it'll prompt us to save. Let's say yes. Let's give it a new name. So let's call this Shimmerverb. I'm going to call this BAS for basic. All right, so Shimmerverb basic. So we haven't got any of those EQs or anything in between that, but we can put those in. So if we want to go back into this. We can put reverbs, or no, sorry, we can put EQs and choruses in between these if we want. Okay. Right, so if we set this send to 100%, we can now adjust it with a slider and switch 5. So if I turn switch 5 on, I can now adjust the amount with slider I. Just without it. So there we have it, ladies and gentlemen, the Shimmerverb on the Kurzweil. Guys, hit like and subscribe if you like this sort of content. I do not just Kurzweil stuff, I am doing content on Eventide at the moment. And what else have I been doing? Oh, I don't know, I've been doing stuff. We do lots of music and music videos and stuff like that. But yeah, hit like and subscribe if you like the stuff that we do and you want to buy some additional presets for these. I'm starting up subscriber packs for Buy Me a Coffee. So if you come over to Buy Me a Coffee and subscribe, you're going to start getting access to bunches of presets. I upload these initial patches, so the work that I do in this video, I'll upload to the Mastering Fast forums. We've got a download manager there, so we keep all the stuff in there. And yeah, so that's where you can get hold of it. And I'm going to start building batches of presets for people so they can get the basic algorithm. You can basically get that for free. But yeah, if you want a whole bunch of preset content for it, throw us a few bucks, buy me a coffee, and they're all yours. Anyway, thanks for tuning in, and I will see you guys all again soon. I hope you're having a wonderful Christmas, and let's hope for a productive and very musical 2022. Thank you very much, guys. I will see you again soon.